Solve the system of linear congruences. X is congruent to 2 mod 3, X is congruent to 3 mod 5, X is congruent to 2 mod 7. Here they have given 3 system of linear congruence in the form X is congruent to A1 mod M1, X is congruent to A2 mod M2 and X is congruent to A3 mod M3. So first step we have to take A1, A2, A3 value and M1, M2, M3 value. So A1 is 2, A2 is 3 and A3 is 2 here. Similarly M1 is 3, M2 is 5 and M3 is 7. Next step, first we have to verify the condition, that is the GCD of Mi, Mj is equal to 1 for all I not equal to j, the time not equal to j. For that we have to find the GCD. Here we have given M1, M2, M3 value. So we have to verify that M1, M2 is equal to 1, M2, M3 is equal to 1 and M1 and M3 equal to 1. That is GCD of M1, M2, M3 are relatively prime. So we have taken here 3, 5, we have to verify that 3, 5 GCD is 1 and 5, 7 GCD is 1. Similarly 3 and 7 GCD is 1. In the previous videos we studied how to find the GCD for bigger value. For this smaller value it is very easy to find the GCD in this form. Here I have taken for this value, that is the GCD of 3 and 5. Here the GCD of 3 and 5 is nothing but we have to find the greatest common divisor for 3 and 5. We know that for 3 the divisors of 3 is, here the 3 is divided by the value 1 and 3. Here 3 is divided by 1 and 3 itself. So the divisors of 3 we can take this as 1 and 3. We can call this definition as 3 is a prime number, because prime, the definition of prime number says the number which is divided by 1 and the number itself is nothing but a prime number. So the divisors of 3 is 1 and the 3 itself. So we can call 3 as a prime number. So for the prime number the divisors are the number 1 and the number itself. So similarly for the divisors of 5 is, here 5 is the value they have given for, so we have to find the divisor for 5. That means the divisor of 5 is 1 and 5 itself. Here 1 divides 5 and 5 divides 5. So we can take this as 5 is a prime number. Also we know that 5 is a prime number because 5 is divided by the number 1 and actual number itself. So the divisors of 3 is 1 and 3 and divisors of 5 is 1 and 5. So among these two we have to find the greatest common divisor, means here 1 and 3, here we have 1 and 5. Here in these two the common divisor is 1. That is the greatest common divisor of 3, 5 is equal to 1. We can easily find the greatest common divisor using this method. Similarly for 5 and 7, here the divisors of 7 is 1 and 7. In these two the greatest common divisor is 1. Therefore we can take this as GCD of 5 and 7 as 1. In the similar way we have to verify the GCD of 3 and 7 is 1 or not. After verifying the GCD, next step we have to find the product of M1, M2, M3. Here we have 3 congruencies, so we have to take M1, M2, M3. So we have to take the product of M1, M2, M3 as M, which is equal to, here M1 is 3, M2 is 5 and M3 is 7. So 3 into 5 into 7 is 105. Therefore we get small letter m as 105. After obtaining m value, next step we have to find mk value with a formula, that is mk is equal to small m by small mk for k is equal to 1, 2 and 3. So we get capital M1 as m is 105 divided by mk, that is m1 is 3, 105 by 3 is 35. Therefore we get m1 as 35. Similarly capital M2, which is equal to m is 105 divided by m2 is 5, that is 105 by 5 is equal to 21, that is the value of m2. Similarly m3 is equal to m is 105 divided by m3 is 7, so 105 by 7 is nothing but 50. After obtaining m1, m2, m3 value, next we have to consider the congruency as mk x congruent to 1 mod mk for k is equal to 1, 2, 3. Here we have k as 1, 2, 3, so we have to consider 3 congruency, that is mk, that is k is equal to 1 means m1 is 35, that is 35x congruent to 1 mod m1 is 3. In the similar way m2 is 21x congruent to 1 mod m2, small letter m2 is 5. m3, that is m3 is 15x congruent to 1 mod small letter m3 is 7. So we obtained 3 congruency. Next step, by the inspection method we have to find x value, so that we have to satisfy the unique condition. So by inspection method, if we substitute x value as 1, we have to take first value as 1. If you substitute x value as 1 means 35 into 1 is 35 is congruent to 1 mod 3, that is 3 divides 35 minus 1 is 34. we know that 3 does not divide 34. So we have to take a next value, that is if we substitute x value as 2, that becomes 35 into 2 as 70. 70 is congruent to 1 mod 3. That implies 3 divides 70 minus 1 is 69. Obviously 3 divides 69. Hence we can take by inspection method this for this value, that is x1 as, that is if we substitute x value as 2, the congruence is satisfied. In the similar way, if we substitute x is equal to 1 means 21 is congruent to 1 mod 5, that is 5 divides 21 minus 1 is 20. Obviously 5 divides 20, therefore x2 is 1 here. For this, if we substitute x value as 1, 15 into 1 is 15 is congruent to 1 mod 7, that is 7 divides 15 minus 1 is 14. Obviously 7 divides 14. Therefore by inspection method, x1 is 2, x2 is 1 and x3 is 1 are satisfied. After obtaining x1, x2, x3 value, m1, m2, m3 value and a1, a2, a3 value we already known. Finally, the unique solution of system of linear congruence is given by the formula x is congruent to a1, m1, x1 plus a2, m2, x2 plus etc. up to ar, mr, xr under mod m. Here we have k is equal to 1, 2, 3. Therefore, we equation or congruency reduces to x is congruent to a1, m1, x1 plus a2, m2, x2 plus a3, m3, x3 under mod m. We have to substitute all these values. We get x is congruent to a1 is 2 into m1 is 35 into x1 is 2 plus a2 is 3 into m2 is 21 into x2 is 1 plus a3 is 2 plus m3 is 15 into x3 is 1 under mod 105. Here m value is 105. You have to substitute m value. Next step, after simplifying the value, we get as x is congruent to this value becomes 140 plus this value is 63 plus this value is 30 under mod 105. If we add these three values, we get x is congruent to 233 mod 105. But this value is greater value, so we have to reduce to a lesser value. For that, we have to consider like this. Here we have to divide 233 by 105. We get some smaller value, that is smaller remainder. Therefore, we can take that is 105 into 2. If we take 105 into 2, we get 210. So next step, we have to subtract 233 by 210. We get 23 as a remainder, which is less value. So in the place of 233, we can take it as 23 because 233 is congruent to 23 mod 105. Therefore, we can take this as x is congruent to 23 mod 105 is a unique solution for a given system of linear congruence. This completes the problem.